Hi and Assalamualaikum everyone. Okay, so today we will start with chapter 5. Okay, we will continue with chapter 5, states of matter. So basically in states of matter, okay, kita akan cover for 3 major subtopics, iaitu gas, liquid and solid. Okay, so for the first part sekarang ni kita akan cover dahulu untuk gas. Alright. So untuk gas, kita akan cover the main 3 gas laws, iaitu Boyle's law, Charles' law and Avogadro's law. Okay, so you must understand what are these laws. Okay, so what are the constants dan apa dia punya variables, and then you must be able to sketch and interpret the graph of Boyle's and Charles' law, and also you must be able to perform calculations involving the gas laws by using their respective formula. Okay, right, so this is just to show you the difference in the particle arrangement in solid, liquid and gas. Okay, so I believe you have learned this one also previously in secondary level. Okay, so kita just recall balik sikit saja. So for solid, the particles in solid are in close contact ataupun they are arranged in closely packed arrangement. Okay, or densely packed arrangement, okay, in the specific lattice. Okay, lattice means dalam kedudukan yang fixed lah, okay, fixed position. And for liquid, they are separated, the particles are separated by greater distance rather than in solid. So in liquid, okay, we can see that there are still a few ruang kosong between the liquid particles, okay, which allow the liquid to flow. And then for gas, the particles are in greater distance between each other, okay, much greater than in liquid and also in solid. Okay, so that is actually the perbezaan in terms of the particle arrangement in liquid, solid dan juga gas. Okay, and for the interconversion of the phases, okay, kita boleh tengok daripada sini. Okay, solid can freely forming liquid and then into gas, and the process can repeat, okay, once again from gas, liquid dan juga solid, okay, dengan melalui beberapa proses. Okay, so from solid to liquid, this is so-called melting process. From liquid to gas, it is boiling process. And then reverse balik, gas to liquid, this is condensation process. And liquid to solid, this is so-called freezing process. Okay, and we can simply convert the solid, okay, straight away to the gas, okay, tanpa melalui liquid, and that is so-called sublimation process. And from the gas also can freely convert to solid, okay, during deposition process. Okay, and this is a few physical characteristic of gases. Okay, gases are compressible. Kenapa? Because they have a lot of space, okay, between the gas particle. Okay, they are low density. Okay, and they can diffuse quickly. Why they can diffuse quickly? Satu, because of the presence of the empty space. Dan yang kedua adalah due to the small particles of the gas lah. And then they can fill up the container uniformly. Okay, this one can also relate dengan the third points of yang tadi tu. Dan juga they exert pressure uniformly. Okay. So, to measure the pressure is force over area. Okay, pressure equals to force over area. So when pressure is increased, area will be decreases. Okay, or when pressure is decreased, area will be decreases. Okay, so they have the inversely proportional, okay, punya hubungan. And then these are the few unit of pressure yang quite important for you, okay, which is ATM, mmHg, torr dan juga Pascal. Okay, so you have to memorize, okay, tentang the unit conversion of the gas, okay, di mana okay, di mana for 1 ATM of gas bersamaan dengan 760 mmHg. Okay, so 1 ATM also equals to 760 torr, then this 1 ATM also equals to 101,325 Pascal. Okay, so this unit conversion, okay, you mesti kena tahu. Dan ingat, and you must know on how to convert from ATM to mmHg, and how to convert from ATM to Tor, dan juga ATM to Pascal, okay, and vice versa. Okay, so next we go to the gas laws. So basically untuk gas laws, okay, so untuk gas law, ada 4 gas law yang kita akan cover. Okay, apa dia? Iaitu they are Boyle's law, and then we have Charles law. Okay, next we have Avogadro's law, and the last one, ideal gas equation. Okay, so let's see the Boyle's law first. So Boyle's law states the relationship between the volume of the gas and its pressure. Okay, so Boyle's law merekodkan hubungan di antara volume dan juga pressure of the gas. Okay, pada mana? Pada constant temperature and number of mole. Okay, so macam mana hubungan di antara pressure dengan gas ini? Okay, so untuk Boyle's law, okay, so Boyle's law record the relationship between pressure and volume of the gas. Okay, so di mana pressure is directly proportional to 1 over V. Okay, ataupun in other words, we can say that pressure is inversely proportional to the volume. Okay, so when we insert the K, which is proportionality constant, okay, so K is the proportionality constant, okay, so it will become P equals to K1 over V. Okay, ataupun when you bring the V, okay, ke sebelah kiri, so it will become PV equals to K. Alright, now, so macam mana nak nampak hubungan di antara P dengan 1 over V ni adalah, let's say kita ada balloon. Okay, dan dalam balloon ni ada gas particle. Alright, okay. Sekejap. Repeat balik. This was quite small. I akan ambil a bigger balloon. Okay, let's say we have a bigger balloon. Okay, with the gas particles inside the balloon. Okay, now, and then this is katakan at low pressure. Okay, so when pressure is low, you can see that the gas volume atau the volume of the balloon ni adalah bigger, so V is higher. Okay, now next, what happens if you press the balloon? Okay, so what does it mean by press? So press meaning that you apply higher pressure towards the balloon. Okay, so when you press the balloon, what will happen to the size of the balloon? Maybe it will become decreases. Sebab you press dia, you kempiskan dia. Okay, so when you press the balloon, meaning that when you apply the high pressure towards the balloon, maka the size of the balloon will be decreases. Alright, so bila P is tinggi, V will be lower. Okay, so when you press some more, maybe the balloon will be explode. Alright, bila you patah balik ke sebelah belakang, okay, when you release, okay, the pressure, okay, you dah tak press the balloon, okay, so the volume of the balloon will get increases once again. Okay, so this is just to show you the hubungan between pressure and the volume. Okay, meaning that, okay, bila pressure is decreased, the volume will be increased, or when the pressure is increased, the volume will be decreased. Okay, so ini membuktikanlah hubungan, okay, di mana P is directly proportional to 1 over V ataupun P is inversely proportional to the volume. Okay, so bila P tinggi, V akan rendah. So dia hubungan dia terbalik. Alright, now, so when you have two different conditions, okay, so at two different conditions, okay, so the formula akan becoming P1 V1 equals to P2 V2. Okay, di mana ini 1 is the initial quantities and 2 is the final quantities. Okay, right now, again, the hubungan between pressure and volume tadi, okay, this one must be at constant temperature and N. What is N? N is number of mole. Okay, N is number of mole. Okay. Alright, now. And how about the graph? Okay, so untuk graph pula, when you plot or sketch the graph P versus 1 over V, okay, so you akan dapat this graph garis lurus. Okay, you akan dapat graph garis lurus. Okay, macam mana you boleh dapat macam ni? Kita ambil daripada equation ni tadi. Okay, P times V equals to K. So when you bring the V ni ke sebelah kanan, this will become P equals to K1 over V. Okay, so bila you insertkan persamaan garis lurus, okay, dalam this formula, dia akan jadi Y equals to MX plus C. Okay, so dekat atas ni, this is plus 0. Alright, so bila awak plotkan graf garis lurus, so you akan nampak our y-axis adalah P and our x-axis adalah 1 over V, and C, the pintasan is 0. So your graph origin akan start daripada 0. Macam ini. Okay, and M is the gradient. So you can record the M from here lah. Okay, di mana M itu adalah K tadi, proportionality constant. Alright. Okay. So you boleh nampak dekat sini. Okay, when P is increased, so 1 over V will be increased. Okay, 1 over V bukan V. Tapi bila P increase, okay, V will be decrease. So to record this hubungan, okay, maka kita akan plotkan graph P versus V. Okay, you can plot the graph of P versus V. Okay, di mana graph P versus V, you akan dapat hubungan exponential. Okay, ataupun curve. Okay, so apa maksudnya graph ini? Maksudnya adalah at this point, for example, okay, you boleh nampak our nilai of P is higher. So when P is higher, tengok pula nilai dia punya V. Okay, so this is the V nilai. So when P is higher, V is lower. And you compare dengan this point over here. Okay, so untuk this point, when P is lower, okay, so the V here is higher. Okay, so this graph can show you, okay, the hubungan between pressure and volume according to Boyle's law clearly. Di mana hubungan antara pressure dengan volume adalah inversely proportional. Okay, so itu semua dah ditunjukkan dalam I punya slide. So I akan go through mana yang penting sahaja. Okay, and then the rest of it you boleh boleh refer kemudian lah. Okay, boleh buat self revision kemudian. Okay, so let's see one example over here. Right, for this soalan, a sample of chlorine gas occupies a volume of 946 ml at a pressure of 726 mmHg. Calculate the pressure of the gas in the same unit if the volume is reduced to 154 ml at constant temperature. Okay, now, what you can do from the soalan and what you have to do from the soalan adalah identify the nilai given in the soalan. Okay, identify what are the nilai given in the soalan. So, dalam soalan ni kita ada volume, this is V1. Okay, the first condition, at a pressure 7 to 6 mmHg. So, this is the P1. Calculate the pressure. Okay, you must find the P2. If the volume is reduced to 154 ml. So, this is the V2. Okay, so from the soalan and from the nilais given in the soalan, okay, you already have P1 value, you have V1 value, and you have V2 value. So these three values dah ada, and then you have to cari P2 value. And it is said to you, it is mentioned to you at constant temperature. Okay, so by having that information, okay, kita dah nampak, okay, apa yang berubah dekat sini? Pressure dan juga volume. Okay, so when you have two different conditions, two different pressure dan juga volume, maka you kena pakai Boyle's law formula. Yang mana satu? Yang ini. P1 V1 equals to P2 V2. Okay, at constant temperature. Alright. Okay, so by knowing the formula, okay, which is P1 V1 equals to P2 V2. Okay, so you just insert the nilai into the formula sahajalah. Okay, so P1 we have 7 to 6 mmHg times the V1 946 ml. Okay, equals to P2, the one yang you nak cari, dan V2 is 154 ml. Okay, so later to find the P2, okay, you will need to do this operation. Okay, so you can cancel the ml unit. Okay, so you buatlah dia punya apa, mathematical operations. Okay, and you will get your jawapan nanti will be 4460 mmHg. Okay, that's simple. Alright. Okay, and we have one example over here. Okay, so you boleh cuba jawab lah. Okay, jawapan pun dah ada dekat sini. So this jawapan must be in 4 decimal points. Ingat 4 decimal points. Okay, kalau ada lah. Okay, the second gas law adalah Charles law. Okay, second gas law adalah Charles law. So Charles law states the relationship between temperature and volume of the gas. Okay, di mana volume is directly proportional to the temperature. Okay, volume is directly proportional to the temperature in Kelvin. Okay, and here the pressure and the number of mole of gas are constant. Okay, pressure and number of mole adalah constant. So Charles law akan merekodkan hubungan di antara temperature dan volume of a gas. Okay, temperature dan volume of a gas. Okay, and then they are mathematically expressed sebagai V directly proportional to temperature. Okay, so when you insert the K proportionality constant, so it will become V over T equals to K. Okay, now so untuk Charles law, okay, Charles law states the relationship between volume and temperature, di mana dua-dua ni adalah they are directly proportional. Okay, so when you insert the pemalar, it will become V equals to KT. Okay, V equals to KT. Alright. Okay, now, for example, kita ada satu balloon, sorry. Okay, so katakan this is the balloon at low temperature. Okay, what will happen to the balloon if you increase the temperature? What do you think? Yes, the balloon will get expand. Okay, the balloon akan expand. So at high temperature, balloon will expand. At lower temperature, balloon will get smaller. Okay, so daripada sini you boleh nampak at lower temperature, size of the balloon will be decreases. Okay, so volume of the gas will be decreases as well. And then when you increase the temperature, bila you panaskan the balloon, okay, when T increase, maka the size of the balloon will get bigger. Okay, bermaksud volume of the gas will be increased. Okay, boleh nampak? Okay, now, kenapa benda ni jadi? Okay, so untuk temperature, okay, benda yang melibatkan temperature, you can relate with kinetic energy of the gas. Okay, dalam balloon ni tadi ada isi dengan gas. Okay, so yang titik ni, ini adalah gas particle. Alright, so when you increase the temperature of the balloon, so dalam balloon itu ada gas particle. So by increasing the temperature of the balloon, so apa yang akan jadi adalah kinetic energy of the gas particle will be increases. Okay, kinetic energy of the gas particle will be increases. So bila kinetic energy of the gas particle will be increases dalam balloon tersebut, so apa yang akan jadi? The gas particles akan collide with the wall of the container dan collide dengan sesama mereka, okay, at higher energy. Okay, so when the colliding, okay, between the gas particle dengan the dinding of the wall of the container, the wall of the balloon, so itu yang akan menyebabkan, okay, size of the balloon tu akan mengembang. Alright, so daripada sini you boleh nampak, okay, the direct relationship di antara temperature dan juga volume. Okay, so that's why untuk Charles Law, okay, Charles Law akan rekodkan hubungan di antara volume dan juga temperature di mana mereka adalah directly proportional. And not to forget, okay, untuk Charles Law yang constant adalah pressure and N, number of mole. Okay, so P dan juga number of mole adalah constant. Okay, so you boleh nampak juga dekat sini tentang movement of the gas in the capillary. Okay, so at lower temperature, okay, you may see this is the volume of the volume yang akan dioccupy oleh gas. But when we increase the temperature of the gas, okay, ataupun temperature of the bekas, okay, you boleh nampak. Okay, so now the gas has expanded. Okay, so the volume of the gas has been increased. Alright, okay. So at two different temperatures, okay, at two different temperature and volume ataupun at two different conditions. Okay, conditions dia apa? V dan juga T lah. Okay, so at two different conditions, the formula akan jadi, okay, jadi macam mana? Daripada tadi, okay, V equals to KT. So bila you bawa T ke sebelah kiri, dia akan jadi V over T equals to K. Okay, so this is at one condition. Okay, ini adalah formula untuk one condition. Okay, so bila you ada two different conditions, okay, so the formula akan becoming V1 over T1 equals to V2 over T2. Okay, di mana yang the first one ini adalah initial condition and the second one adalah final condition. Alright? Okay. Okay, now, before that, bila awak nak tunjukkan graph, okay, graph apa? Graph, katakan graph untuk V equals to KT. Okay, so bila awak plotkan graph, okay, di antara volume dengan temperature, okay, so awak nampak bentuk dia macam mana? Okay, so bentuk dia akan jadi, you apply balik persamaan graph garis lurus, Y equals to MX plus C. Okay, so our C is 0, so this is 0, Okay, so y-axis is the volume. Okay, this is here. And the x-axis adalah temperature. Okay, and the K is the gradient. So maka graph you akan start daripada 0. Okay, and before I forget, okay, temperature must be recorded in Kelvin. Okay, temperature must be in Kelvin saja. Tak boleh dalam degree Celsius. So if the soalan give you the temperature in degree Celsius, maka you have to convert into Kelvin. Okay, so the temperature here must be in Kelvin. Okay, so bila volume of the gas, okay, relatekan dengan temperature of the gas in Kelvin, you akan dapat a direct proportional. Okay, apa tu direct proportional punya hubungan antara volume dan juga temperature di sini. Okay, dengan syarat temperature must be dalam Kelvin. Okay, so hubungan ini okay boleh menjelaskan kepada kita juga tentang okay ratio between volume dan juga temperature. Okay, so let's say you ada 2 liter okay of gas at 300 Kelvin. Okay, what happens to the volume of the gas if we increase or if we double the temperature to 600 Kelvin? Okay, so kalau you tak tahu nak agak, you boleh simply pakai formula V1 over T1 equals to V2 over T2. Alright, so you nak cari apa? Nak cari V yang kedua dekat sini. Alright, so untuk V yang kedua, okay, you insert the nilai. So V1 is 2 liter, T1 is 300 Kelvin, V2 yang awak nak cari, T2 is 600 Kelvin. Okay, so you will get the jawapan V2 ni sebagai berapa? Yes, it is 4 liter. Okay, so you boleh nampak dekat sini, walaupun you tak kira, okay, you can still congak ada hubungan di antara volume, okay, yang pertama dengan volume yang kedua. Okay, di mana when the temperature gets double, so supposedly the volume also will gets double. Okay, so V2 tadi berapa? V2 adalah 4 liter. Okay, so when temperature is double, okay, the volume also akan double. Kenapa? Sebab V directly proportional dengan temperature. Okay, how if we have 275 ml of gas in 25 degrees Celsius? Okay, so what happens to the volume of the gas if we double the temperature to 50 degrees Celsius? Okay, adakah V2 di sini will be double from the first one? Okay, from the V1? The answer is no. Okay, kenapa? Because the temperature here is in degrees Celsius. Okay, it is not in Kelvin. Okay, so hanya hubungan bila mana temperature dalam Kelvin sahaja, okay, awak akan dapat when the temperature is double, the volume also akan double. Tapi when the temperature is in degrees Celsius, you have to convert the temperature dalam Kelvin dahulu. Okay, so when you convert this temperature in Kelvin, awak takkan nampak the temperature is actually double. Okay, so to get the correct jawapan untuk V2 dekat sini, maka awak kena kira lah dengan menggunakan V1 over T1 equals to V2 over T2. Alright? Okay, kita cuba ambil satu example dekat sini. So a sample of carbon monoxide gas occupies 3.20 liter at 125 degrees Celsius. Calculate the temperature at which the gas will occupy 1.54 liter if the pressure remains constant. Okay, identify apa info given in the soalan. So here we have V1 and here we have T1. Calculate the temperature. Okay, so you have to kira the second temperature. Okay, di mana you dah ada V yang kedua. Okay, so in this case, okay, So, dalam kes ni awak masukkan dalam formula lah. Okay. So, V1 tadi ada berapa? V1 we have 3.20 liter over T1. Okay. So, now our T1 is 125 degrees Celsius. So, what you have to do first adalah you have to convert this degree Celsius into Kelvin. Right? So, 125 plus 273.15. Okay, so get your jawapan in Kelvin here. Okay, for T1. And then you insert into the formula given. Okay, into the formula yang dekat atas ni. Okay, so I just cut it short. Okay, nanti you balik, you revise and tolong kira specifically. So I just ambil a rough data saja. So for T1, when 125 add dengan 270.15, so you akan dapat it is 398, sorry. Okay, tolong kira balik. So I just pakai number bulat saja ni. Okay, so for your own reference, for your own kegunaan, kena pakai yang ada decimal points. Okay, so this will become 398 Kelvin. Okay, which is from here. And then V2 from the soalan is 1.54 liter. And you nak cari T2. Okay, so rearrange the formula. So maka you akan dapat T2 equals to 1.54 liter times 398 Kelvin over 3.20 liter. So this liter you can cancel. Okay, so maka T2 nanti you akan dapat 192 Kelvin. Okay, so please calculate once again, okay, during your self-study nanti. Okay, settle for that one. Okay, so there is one example here, so you can try answer the soalan. Okay, jawapan pun dah ada. Okay, so next will be the Avogadro's law. So Avogadro's law states the relationship between the volume and the amount of gas. Amount of gas, which is the number of mole of the gas at constant pressure and temperature. Okay, and the volume of the gas is directly proportional to the number of moles of the gas. Okay, volume of gas directly proportional to the number of mole of gas. So untuk Avogadro's law, so this law states the relationship between V, number of mole, and N, number of mole of gas. Okay, between V and number of mole of gas, and dia hubungan adalah directly proportional. Okay, di mana P and T are constant. Okay, P and T are constant. Okay, so now to show the relationship antara V dengan N dekat sini. Okay, so let's say kita ada a balloon. Okay, with the gas, okay, insert into the balloon, and then later on you blow the balloon. Okay, awak hembus, awak tiup lagi, okay, balloon tu. So bila awak tiup, apa yang akan jadi? So the gas particle akan increases, akan masuk. Okay, bila awak blow, okay, awak tiup, sama ada dengan menggunakan mulut you sendiri ataupun dengan menggunakan pump. Okay, so gas akan masuk ke dalam balloon. Okay, so bila gas masuk ke dalam balloon, okay, so now you boleh nampak, okay, the gas particle, jumlah gas particle dekat dalam ni akan semakin bertambah. Okay, so now when you blow the balloon, apa yang akan jadi? N akan bertambah. Apa dia N? Number of mole untuk gas. Okay, sebab bila awak tiup, atau bila awak blow masuk gas ke dalam balloon, okay, yang asal tadi, so of course number of mole, number of particle ke dalam tu akan bertambah. So bila N is bertambah, so you akan nampak V juga akan bertambah. Okay, so bila V increases, N will be increases. Compare dengan yang asal, okay, sahaja kecil. Okay, pada saiz kecil kita akan ada limited number of mole of particles saja. Okay, di dalam situ. So, this relationship membuktikan hubungan di antara V dan juga N, di mana V is directly proportional to the number of mole of gas present. Alright, so when you insert the pemalar, so V equals to K N. Okay, so bila you plotkan the graph, of course you akan dapat satu graph garis lurus jugalah. Alright, okay, so at two different conditions, so V equals to Kn. So bila you bawa N ni ke sebelah kiri, so maka you akan dapat V over N equals to K, di mana at two different conditions, okay, V1 over N1 equals to V2 over N2. Okay, so this is the initial condition and this is the final conditions. Okay, kita ambil satu example. Okay, before that, recall balik apa yang dah belajar dalam chapter 1 hari tu, iaitu tentang molar volume. Okay, at STP dan juga at room temperature, which is RTP. So, for molar volume of the gas at STP, 1 mole of gas equivalent to 22.4 liter. Okay, at STP. And kalau it is at room temperature, 1 mole of the gas bersamaan dengan 24.0 liter. Okay, so I ambil example yang ini. Calculate the volume at STP occupied by the following gases. Okay, calculate the volume at STP occupied by the following gases. Okay, so now kita ada apa dekat sini? Kita ada at STP. STP, this is 1 mole of gas at 22.4 liter. Okay, at STP, 1 mole of gas equals to 22.4 liter. Okay, dan dalam soalan ni, dia minta kita untuk siapa? Untuk 0.25 mole of oxygen gas. Okay, so we already have the mole here, which is 0.25 mole. Okay, so volume, you can find the volume untuk yang kedua tu lah. Okay, dengan menggunakan darab silang. Okay, kalau you tak nak pakai darab silang, you can use the formula. Formula apa tadi? It is V1 over N1 equals to V2 over N2. Okay, di mana 1 mole ini adalah N1, 22.4 is V1. Okay, 0.25 is N2. Okay, dan awak nak kena cari nilai untuk V2. Okay, so by insert the nilai, V1 is, kita balik kat sini So V1 is 1 mole over, V1 is 22.4 liter over N1. N1 is berapa? Yap, 1 mole equals to V2. So what is the V2? Yang ni awak nak cari. Okay, N2. N2 is 0.25 mole. Okay, so by solving the operations, so you will get 22.4 liter times 0.25 mole over 1 mole. Okay, so the answer you akan dapat 5.6 liter. Okay, I hope this kind of calculation tak adalah macam membebankan you sangat. Okay, sebab it is quite simple. Okay, what you have to do adalah you just have to find what are the infos given in the soalan, and then you have to choose lah the most appropriate gas law, okay, to answer the soalan. Okay, so you may proceed with soalan B. Okay, try to get the jawapan. Okay, and I already give the solution, okay, dalam slide, okay, dekat sini. So you boleh refer lah, okay, kemudian on how to get the jawapan. Okay, and we also have example 6 in the soalan. Okay, so you may try answer the soalan also. Okay, I already provide the solution for you, okay, so that you can refer to the solution. And then, okay, so with that, we have done with the 3 gas laws. Okay, so tolong buat self revision until the 3 gas laws. And then I akan masuk terus dengan ideal gas law. Okay, ideal gas law. Alright, now, so the combination between Boyle's law, Charles law and Avogadro's law, okay, kita akan dapat satu lagi ideal gas law, kita panggil sebagai, kita dapat satu lagi gas law, kita panggil sebagai ideal gas equation. Okay, and the ideal gas equation will describe how the volume of a gas is affected by the changes in P, T and N. Okay, so gabungan of these 3 gas laws, okay, you akan ada a few variables, okay, pemboleh ubah, iaitu V, P, T dan juga N. So the ideal gas law can be used to determine density of the gas, relative molecular mass of the gas, temperature and also the pressure of the gas. Alright? Okay, so by combining these 3 gas laws, Boyle's law, Charles law dan juga Avogadro's law, okay, by combining these 3 gas laws, maka you akan dapatlah ideal gas equation. Okay, di mana combination of these 3 gas laws, okay, the formula akan becoming yang ini. Okay, so bila V is directly proportional to T N over P, okay, so when you insert the proportionality constant dekat dalam tu nanti, maka you akan dapat the other gas equation is PV equals to nRT. Okay, di mana R is the gas constant and the nilai of the gas constant adalah sama ada 8.314 ataupun 0.0821. Okay, so gas constant, since we have 2 gas constants value, so mana yang paling sesuai kita nak pakai untuk gas law? The answer is of course yang bawah lah. Okay, kenapa? Sebab kita ada terms pressure dekat sini. Okay, so 0.0821 liter ATM per Kelvin per mole. Okay, so the temperature must be in Kelvin. Okay, so gas that obey the ideal gas equation is known as ideal gas. Okay, so for calculation purpose, you have to pakai the correct unit lah. Okay, so this is just to show you the nilai of the R that should be used in the calculation. So if you have the pressure in Pascal, okay, maka you boleh pakai this nilai of the gas constant, okay, and the unit dekat belakang ni akan berubah lah. Okay, kenapa you pakai this gas constant untuk kalau you ada Pascal punya pressure? Because we have the Pascal pressure unit in the gas constant. Okay, and if you have the pressure in ATM, so you have to choose the gas constant with the ATM unit as well. Alright, so nak pakai gas constant yang mana? Tengok apa pressure, apa unit, okay, of our pressure in the soalan. If the unit of the pressure adalah ATM, maka you have to pilih 0.0821. Okay, kenapa? Sebab the pressure unit in the gas constant adalah sama. Okay, and the pressure and the temperature will always be in Kelvin. Okay, so kalau katakan let's say you tak ingat, okay, the nilai of the gas constant, okay, you can also cari, okay, the nilai of the gas constant dengan menggunakan this hubungan lah, this formula. Okay, R equals to PV over NT. So masukkan the nilai constant dekat sini, maka you akan dapat nilai of the gas constant. Okay, tapi not to worry, because the value of the gas constant is a constant value. Okay, so this one should be given in the final exam as well. Okay, dalam dalam sheet yang ada all the constant. Okay, alright, now so let's see this one example. A steel off tank has a volume of 438 liter. Okay, labelkan dulu. Ini volume. And it's filled with 0.885 kilogram of oxygen gas. Okay, so ini apa? Ini adalah mass. Calculate the pressure of this gas at 21 degrees Celsius. Okay, so this is the temperature. And you have to kira the pressure. Okay. So now, from this soalan, okay, kita boleh nampak bahawa you tak ada langsung any two different conditions. Okay, so apa yang you ada adalah we have the volume, we have the mass, we have the temperature, and you nak kena cari pressure. Okay, so there's no two different conditions. Okay, you memang ada solely V, mass, temperature, and nak kena cari pressure. Okay, so daripada mass, what you can get from the mass? Of course, from the mass, you boleh cari N, number of mole. Okay, so now you have the V, N, and T. Okay, you nak kena cari P. So, which formula you should use in this soalan? Yes, so the answer is by using ideal gas equation. PV equals to nRT. Okay, so to get the pressure, so P equals to nRT over the volume. Okay, so from this soalan, okay, we can find the number of mole. Kita boleh cari number of mole. Daripada mana? Daripada mass. So from mass, find the number of mole of the oxygen gas tadi. Okay, and then you may insert into this formula. Okay, R is the gas constant. Okay, R is the gas constant. Nak pakai yang mana? You may use 0.0821. Okay, with their respective unit as well. So salin semua unit, okay, in the middle of the calculation. Temperature is given 21 degrees Celsius. So please make sure you convert the temperature into Kelvin dahulu. Any temperature in gas laws must be converted into Kelvin. Okay, and the volume of this gas adalah 438 liter. Okay, 438 liter. Okay, so untuk unit of volume, okay, you nak pakai unit apa? Liter ke ataupun ml? Okay, the answer is you must refer to the unit of the gas constant R. So our R unit tadi adalah dm cube, which is liter. So maka this volume must be in liter. Alright, so by insert all the values into this formula, maka nanti awak akan dapatlah nilai pressure. Okay, and the pressure must be in atm. Okay, so try to answer this soalan by your own and check the jawapan over here, and please make sure you get your jawapan until 4 decimal points. Okay, this is not yet the 4 decimal points. Okay, let's see next example. Okay, we have, what is the pressure? You have to find the pressure in a 200 centimeter cube vessel. So this is the volume. If 12 gram of methane, this is the mass of the methane, is heated to a temperature of 40 degrees Celsius, and this is the temperature. So once again, okay, you ada apa? You nak kena cari P, and you have the V, you have the mass, and you have the temperature. So tiga benda ni you ada. Okay, so from the mass, of course, you can find the number of moles. Alright, so by having these 4 variable dekat sini, maka to find the pressure, okay, you akan pakai once again formula P equals to nRT over V. Okay, so from the mass 12 gram, you convert into number of mole, maka you akan dapat 0.75. Okay, and the gas constant, okay, what is the gas constant? The gas constant is 0.0821. Okay, so liter atm per Kelvin per mole. Okay, so times dengan siapa? Alamak, sorry, tak cukup tempat. times dengan temperature. So temperature is 40 degrees Celsius. You convert into Kelvin, maka you akan dapat 313 Kelvin, okay, over the volume. Okay, and the volume is 200 centimeter cube. So 200 centimeter cube also equivalent to 200 ml. Okay, so in this value, volume, we have to convert into liter. Kenapa? Sebab we have liter unit in the gas constant. Okay, so it will become 0.2 liter. Okay, so by having all these values and dan juga unit, so we have mole and per mole boleh cancel, Kelvin and per Kelvin, liter dan juga liter. Okay, and then by doing all these operations, darab, bahagi dan sebagainya, you akan dapat your jawapan as 96.3 atm. Again, this is not the 4 decimal points. Try to get your jawapan until 4 decimal points. Alright? Okay. So, with that, habislah untuk gas laws. Okay. So, please do your self-study. Okay, dan tolong jawab a few example soalan dalam slides ini. Alright. And then later on, I akan bagilah a few soalan tutur yang you should answer untuk gas laws. So, our next lecture will be the kinetic molecular theory untuk gas. Okay, so with that, thank you and Assalamualaikum.